recording started. Okay, can you see that the recording started? All right. So last time we talked about how to bring C2D file into OpenSim using TRC. Like basically that they will become TRC and motion files. After that, we want to know how to do this overview like OpenSim workflow, which means from going all the way from the data to kinematic, kinetic, joint moments, as well as the muscle activation and joint reaction forces, etc. So you can see here we have inverse parabolum, inverse kinematic, dynamic, substitution. So we can do all these basically workflow and using those codes or scripts that I shared with you. Now let's have a look at, yeah, this is the overall idea here, basically how it works. So I'm going back to where we were in terms of the modeling. So you remember we defined the trial, all right? And then we export the trial using run OpenSim. So these trials all the way. And then they're all written here. So if you have, for instance, data here, then they're all written, for instance, like that. Okay. And from here, we want to write like first scale the model, then inverse kinematic and so on. But in order to do that, we need to have this OpenSim requirement, which means XML files and the generic file, etc. So these are all here. All right, so you should have these OpenSim requirements that are prepared, and I prepared them for different scenarios. For instance, inverse dynamic, you can see ID XML target search is the name of what this project is about, but it doesn't matter. So basically, you can see it has gun reaction force and the setup file for the inverse dynamic. So you can have a quick look at it. So you see what's going on here. It gets the data, it gets the results, the OSIM file, the time range, and we can change all these things as well in the code, all right? And the rest is pretty much the same idea. If you want to do the scaling goes here. You need all these files, all right? And then based on them, we manipulate the system according to the codes that we have written here. So this is getting just from C2D file, TRC and motion file, and then still one of the things that we are still working on is the EMG. So because OpenSim hasn't released it, maybe hopefully soon they will release it using their API. We can get the EMG, then we can add to here, and then we'll be fine. But this is so far is TRC and motion, and then the scaling system. So in order to scale it, so this trial we want to give it as I told you here. So this is the where is the data? Your data here. So we have, for instance, we work on this C2D file, right? And then it goes all the way, gets just the source and the destination. Source, remember, source goes to that OpenSim requirement. Can you see that? And gets all the requirements. And then the destination is where the results will be written. And after that, the scaling process will begin. So sources, destination, and the changes. So changes I've made here is, so you get the mass. So this is something critical. You have to make sure in the beginning you really define everything. So basically, you get all the trials, the name of them. Then you basically go through the trials and then find their names. And based on their names, so you need to go. This is something that I've written somewhere else, but you get the mass, which means that how much they weigh each person, right? Because that has to do with the scaling system. So you need to have this one as a matrix, all right? So for now, I just assume this is something. This is like just one. We'll give it a number, and then we'll. And the other one is I've locked some joints like feet, for instance. All right. So this is something that you can actually make changes here as well. So these are the changes that I mentioned. And when you go to scaling process, open the scaling process, you can see here, these are the needed files, the XML files and stuff. All right. And you just need to do as simple as that. So you have this, you can actually run these things standalone. So see that I just run this line, and then I run according to your data. This would be it. So I'll give it this one. Does it make sense?
Yes.
Let me see if there's something wrong here, because of course we don't have these and that. I just do that and do this and do this and do that. Okay. And then basically that's it. So changes I put here, as well as the changes, also put changes mass, let's say 80 kilogram. All right. I just put that as well. And when you run this one, are you following? Is
Yes.
it, yeah, is it clear? So when you
Mm-hmm.
run this one, so I just want to show you what is going to happen here. So you can see that I gave it like luck one, mass this, and then I'm going to run this line. So let's go and see. It says basically it's running everything for that, and that's it. And if you go there and you go to your scaled model, you see that this is done.
Okay.
Does it make sense?
Yes. And how we can find about, the errors, RMS error or
Oh, these are the next steps. Okay, so I think I've put them somewhere, but I am not 100% sure. Okay, I think yeah, these are basically coming here. All the errors, everything are written here. Put out. Yeah, you can see. If you go all the way down, basically you can see for this particular person. I think we have done something similar so that we can read these things as well, but I'm not sure if I've implemented here, but you can easily write a code to sort of read this file and then get the results. So does it make sense? So
yes,
make
yeah.
sure that you use the calibration. So this calibration has to be here basically. So this calibration should come from the data, this data, calibration.
Mm-hmm.
So usually what I suggest, because this
What is
usually,
the TRC file?
yeah, TRC file. This calibration is used for scaling.
Mm-hmm.
Okay, so I usually what I do is I ask everyone to go to Mocha again. It's for scaling. You don't need a lot of data, so maybe you need like around 10, 20, maybe 30 frame.
Mm-hmm.
So when you are there, so you can actually, because the calibration we did was quite long, right? So you see here the calibration is about, yeah, it's like 1,000 frame, okay? But this person is standing. So basically maybe what you can do is just, you can reduce it all the way to like 400 frames and things like that, so that this is the computational time that you're saving. But if you don't care, you can just leave it like that. Does it make sense?
Yes, yes.
But one important thing is, one very important thing is, apart from the fact that you need all those files, you need this calibration for scaling process.
Okay.
Okay, so two major things before that is one is one is these two, mass and lock. Okay, so you want to
Mm-hmm.
lock it or not, depending on how confident you are in the foot joint. So I locked it because I don't feel that we have a really good markers sets for that. That's why I just lock it. And then what else? When I say lock the foot, I mean those were like it's not just the ankle, the actual foot itself, because we have a few, joints over there. So I fixed those ones. And then the rest is quite simple. Okay.
Okay.
All right. Any questions so far for this?
No, that's okay.
So the rest, again, as you go forward, inverse kinematic, inverse dynamic, static optimization is the same.
Mm-hmm.
So the idea is exactly as you see. You just need to add the path of the whole, what do we call it, them files. But I usually suggest that you go to this file and run it as I did for just one person. All right. And I have an example here, usually. use your own, just make changes to whatever it is you can see here, and then destination, and then set a file, and then run. And if there's nothing wrong here, then you can actually run the whole process like this loop. Make sense? So
Yes.
especially for IK, after you did the scaling and you have the TRC file stuff, IK, ID, they are very simple. They must be very simple, because you don't need chain. You don't really change a lot. So you can just have a look at these files that I shared with the OpenSim requirements in terms of IK. So you see, you just had one simple immerse kinematic, And for your own benefit, you can actually come back and let me show you something here. Come back and check a few things, like you did the scaling and then the scale setup has changed here. You can see this is, let me see, 8. Scale 7 didn't change here. Scale setup. The codes, data here. Scale. So scale setup. So it has some files here. Got it? And you see that's basically these setup files are being made just today. You can see.
Yes.
All right. So you can actually have a look at these files and see if everything really matches with what that particular data that you are looking for. Okay. And the same is for immerse kinematic setup. You don't have it here, but if you run it, you basically go through. You can double check it here. All right. So I've separated them. So immerse kinematic setup and immerse kinematic results, so that you can actually double check. Okay. All right. So I think this is pretty much it for this part. And then static optimization, the same idea. Like you're adding the M files, your source, your destination, and again you can see here what you need to do. And this one here that I say is RRA scaled or not. So maybe that's a little bit not advanced, but what I have considered here is, do you want to have RRA, the static optimization, use RRA result to run it or not? Just inverse kinematic. Does it make sense?
Yes.
So if yes, if you put one here, so you need to do RRA in advance, then run a static optimization. But for our purposes, maybe it doesn't matter. Just put in a -1 and you can just keep working. And what else? I think these are, where were we? Oh, sorry, I just, no. Okay, then, okay, that's a tricky part. Okay, after you did this, all right, so you have image kinematic, image dynamic, and optimization. So what is next, do you think?
I don't know.
So you have all the results.
Visualize our results.
Very good. So in order to visualize the result, you need to, what actually I've made here, I think this is actually a cool feature of this, and all these scripts is, you have all these results. Let me show you. For instance, I have all these results for every single person. You see here, but you don't want, whenever you want to get a result, you don't want to go through all these results and then plot them or something like that. Well, what you want to do is you want to sort of collect them all in one file. Then whenever you need that, so you actually just run that one. So basically, you can see here IKs I'm saying here. So this IKs includes all these results for this particular person. And this code does it for every single, for TRCs, for IKs, for IDs, for SO and GRF, and we can actually add whatever we want. So does it make sense? So if you look at this, these files are like, let me just run this one, for instance. If I run this IKs, so you see that there are like 53 people, 53 trials. And as you can see here, I have each trial, all these trials names, right? That's why I said the names are critical, because all the way I'm just using the same name, and then the data accordingly. Make sense?
Yes.
And that's it. And if you want to plot this, so you already plot that. Okay? As easy as that. So basically, you can see here, then you can do all sort of manipulation. Let's say 50, and that's it. Right?
Yeah.
So the same idea is for, like, you can type SO, whatever, depending on if you collect them all, basically what I've done is, let's say ID or SO results. So I have SO results and then SOs here, right? And then in SOs means the static optimization results, the same. Everything is there, right? So you want this particular person's data, and for all these muscles, right? That's it. Right?
Right. Good.
So you probably have noticed how difficult it could have been, like visualize everything, just.
Yes. Yes.
But this is like a game changer. You can easily plot anything you want and just manipulate everything. You know what I mean? And everything is with your hands. So because you don't want to deal with any of the simulation. You already done the simulation. You already done the results, and now collect the results. So let's go back to the codes. Yeah. So after you did all these simulations, here is data collection for all these people. So the type of things that we collect, TRC, as I said, IK, ID, SO, whatever you want. Then you're basically using this simple code to write all these, basically it's not that simple, but it goes into another file. Yeah, this one, right? So basically I write and I read basically and save everything all the way to this. Where is it? I save them here, like save IK, save GRF, and so on. Make sense?
Yeah.
Okay. I think that's enough for today, because it's quite a lot of information, right?
Yeah. Yeah.
So we are almost there.
What about the gate event detection?
Oh, that's the next step here. So after you collect data using Gait, TRC Gait event, you just run this one. It produces all the Gait events and stuff. Make sense?
Yes.
So basically, a GRF Gait event will do that. Here, this file, and it runs just to give the source, which means basically that person, and then it produces Gait events for every single person. How does it do that? How does it show it? This is the way it shows that. It produces in GRF, if you go there, Gait event, all right? And if you run that, you just copy it here. You can see it again, GRF for this. They're all following the same structure, right? For that particular person, HS means heel strike,
Yeah.
so on,
And what about the perturbation? The instant that perturbation occurs.
That is the deflow file. If you go there, if you find, let me go back to close this one here. The next one here, MOS calculator, MOS here, deflow and MOS. If you go to deflow, run the deflow, it will find, because there might be missing files, the delta speed it will find, and the perturbation. So if you look at that, you can see it actually goes that source again, and C3D files are these names, right? And then you go all the way, so you can have a look later on, and then at the end it finds deflow, the delta speed, perturbation, timing, and missing data. So you can actually find these ones as a result here in the deflow folder. And again, I collect them this way. So you look at dflow. Here you can see for perturbation for every single person. So for instance, W11, because W11 is normal walking, so there's
It
no
doesn't
perturbation.
have to finish. Yeah.
So that's it. And again, even if there's no perturbation, so it will be 999. So there are like trials that no perturbation. Yeah, so you see basically the same. But if there is a perturbation, for instance, here, the initial is this, the outcome, the final is this. This is the frame, I think, framework. Okay, you can actually figure it out what the data look like, or the belt speed. Okay, that's actually another cool thing about this system is basically belt speed for W. This is basically we say W204 means W2, the fourth one. It should be 1.1, right, all the time. But if you look at something with perturbation like this, right, deceleration, so it should go down, right, at some point, right? That's basically with respect to time. Okay. I don't think there's anything missing here. Everything that you want to simulate or basically get results and everything should be here. Okay. So the only thing that we really need to do is really finding key questions, and then quickly getting the results. And of course, getting the results is not that easy, of course, because the missing data, that cleaning up, it's of course the time. We'll work on it. But as you can see here, the overall idea is here, and basically getting from trial selection, TRC motion, scaling, inverse kinematic, dynamic, static optimization, collecting the data, and then doing the 8 event, dflow, and MOS.
And another question, if I want to use the CMC instead of static optimization for calculating muscle forces, I should add another section.
It could be similar to this. I think I've done it before here. Like this is static optimization. And then let me check something here as you asked. I probably have done the CMC here. I'm not sure, but I'm sure that we have done it before, but probably it's not in here. So our RA is like CMC, it's very similar. So if you want to make changes, you can actually make changes to these files and then create your own set of XML file for CMC. You know what I mean? So basically copy all these things and then make changes accordingly. And then create something like this. Make sense?
Yes, yes.
I'm 100% sure we have done it. I think I had a student who was a master's student who really did all of them plus this one as well. So have a look. I don't know where it is, but it's very simple if you want to just add CMC or any other type of simulation.
Because CMC sometimes doesn't run in the OpenSim. You have to change many things, and
it's challenging.
Yeah, challenging.
I recommend you just focus on these things for now.
Yes, yeah, of course, yeah.
Static optimization, everything. So what I can see, what I would suggest is, so I'll tell you more about this after you finish the technical part again. So anything else about this technical stuff?
No, not for now. Thank you for your time. Thanks.
No worries. So let me just finish this. Where was the? Okay, I want to stop this.